of congruent figures are congruent. That's what CPCFC stands for. All right, and this is something we're going to be using when we prove statements. And so that's what we're going to be doing today. Your EQ for this lesson specifically is what can you conclude about two figures that are congruent? And we have one I can statement. I can prove a pair of triangles are congruent using corresponding pairs of sides and corresponding pairs of angles. So last time we took notes, we had this in it, CPCFC, but just to remind you, it says if two figures are congruent, then the corresponding sides are congruent and the corresponding angles are congruent. And there's three properties of congruence that we're going to be looking at and using in proofs today. Okay, and they're listed out here. So the first one is the reflexive property of congruence. Reflexive, okay, it's basically just says that if you have something like side AB, it's congruent to itself. That's the reflexive property. Something is congruent to itself. So that's an example right here. AB is congruent to AB. And then we have the symmetric property of congruence, which says if side AB is congruent to side CD, then side CD is congruent to side AB. So basically, you can reverse the order. It's kind of like when you say 3 plus 2 is 5, so 2 plus 3 is 5 as well. You can reverse the order and it's still true. And then the last one that we're going to be looking at and using is transitive property of congruence. So if it's given that side AB is congruent to side CD, and also it's given that side CD is congruent to side EF, the transitive property says that since this thing here is congruent to that, and that's also congruent to this, then the very first thing, side AB, is congruent to the very last thing. Side AB is congruent to side EF. That's transitive property. So these will show up in our proofs. And so this is the first one we're going to look at. And we have a picture here of two triangles next to each other. And it's given, okay, so this is a statement that's true. Triangle ABD is congruent to triangle ACD. So it's given that these two triangles are congruent. And knowing that, we are going to prove that D is the midpoint of segment or side length BC. Okay, so we're going to use deductive reasoning to prove this to be true. All right, and so we're just going to go step by step here. And the first thing that we're going to look at is this first line. We're going to make the statement that triangle ABD is congruent to triangle ACD. And the reason we're able to say that, the reason on the right-hand side is because it is given to us. It's given to us in the initial statement. Okay, and so that's the reason it's given. The second thing we're going to say is that segment or side BD is congruent to side CD. And the reason we can make this statement is because corresponding parts of congruent figures are congruent. This is the topic of these notes, CPCFC. And then we have a third statement. D is the midpoint of segment BC. BC, this long segment here. The reason we're able to say that is because this is the definition of a midpoint. So you got to think back to when we learned about midpoint, which was, it was a while ago. It was like the beginning of the school year, beginning of Unit 1 when we did midpoint and we did distance. We had those formulas, but you define midpoint of a segment when these two segments are the same length. Okay, so it's right in the middle. And that's an example of a proof. So we proved D is the midpoint of BC with deductive reasoning, putting statements in order and giving reasons for those statements to be true. Okay, so here's another one. And this one you're going to get a chance to actually type on or draw on. We have quadrilateral. Okay, so up the top says given. Quadrilateral JKLM is congruent to quadrilateral MPQR. J, angle J, is congruent to angle K. And so we're given these two statements. That's given. And we're going to prove that angle J is congruent to angle P. All right, so the statements are already filled in. We have to come over here and fill in the reasons. And so this first statement, 1, quadrilateral JKLM is congruent to quadrilateral MPQR. Why is it that we can write this in this box? What is the reason? What would I put here? So go ahead and fill in box 1 with what you think the reason is. And just think back to what did we do on the last problem. You can go ahead and toggle over to your Pear Deck tab. You're going to write a single word. All right, so just looking at first one that popped up, I have 4 responses already, and you guys figured it out. It's given, okay? So 3 of you figured that out already. The first word we're going to write is given, okay? Because it is given to us in the directions, not the directions, in the initial statement, okay? So now for statement 2, the angle of J is congruent to angle K. Why is it that we can put this in this box for number 2? What is the reasoning that it can do that? So the first reason was that it was given. But if you look up here in what was given, there is actually 2 things that are given. There's 2 things shared with us. So go to your Pear Deck tab. And what do you think we'd write in the second box? All right, so this is correct. Given and given again. Our first 2 reasons are both given statements. Okay, so we have on your Pear Deck slide, you should have given written for reason 1 and given written for reason 2. They're telling this stuff in the initial statements. Okay, now we're moving on to statement 3. Statement 3 is not given. All right, it's another reason that we're going to be able to do this. The angle K is congruent to angle P. How can we make that statement? There's a reason that I'm able to make that statement. So I'm going to let you try that. Why do you think I'm able to make that statement? So I like that this person, they're trying to figure it out, okay, and that's what you want to do, is you just want to try right now, okay, I'm going to give you the answer, but I'm just going to kind of go back a couple slides with you. Okay, so if we just look at the last proof, we were able to say that side length BD is congruent to side length CD, because if I have two triangles that are congruent to each other, then CPCFC, corresponding parts of congruent figures, are congruent. And so in this, let me show this instead. The reason why we could say that angle K is congruent to angle P is because we've already established that these quadrilaterals are congruent. So you can use the acronym, I'll use it correctly, CPFC, which means that congruent, corresponding, I cannot type this morning, corresponding parts of congruent figures are congruent. All right. So this is what we're going to put in for the third one. Corresponding parts of congruent figures are congruent. And these statements, our last statement is the thing that we're trying to prove, that angle J is congruent to angle P. And so this very last part, how do I get here? Well, if you look at statement 2, angle J is congruent to angle K. Statement 3, angle K is congruent to angle P. So this is one of those properties of congruence that we had earlier in our slides. So let me just share that with you and go back to right here. Okay, so these are the properties of congruence. Which property, reflexive, symmetric, or transitive, says if something equals something else, then that something else is equal to something else, and that first thing is equal to the last thing? That's kind of hard to understand. Okay, so basically what it says here, this is transitive. So this first thing is equal to that thing, and then that thing is also equal to this thing. So the first thing is equal to the last thing. That's transitive. Okay, so that's actually what we're going to put for our last box. Oops, too far. Good. This person's on it. Okay, so I'll leave you right here on this slide, so you could type in transitive property of congruence. And I'll share this with you. I'll show you how it looks. So if you're in the Meet, you can see what I'm typing, and then you can add it to your slide. Transitive property of congruence. Okay, because we did J is to K, K is to P, therefore J is to P. And I did see someone trying to type something along those lines, which is great. Okay, so this is a proof. You have a test in finals week, and you will have one proof on there, and it'll be more of like filling in the reasons of why things are true. Okay, so this is good. And I'm fine with you using this acronym, CPCFC. Just make sure you know what you're actually writing. Corresponding parts of congruent figures are congruent. Okay, and so this was the person, they started with that, and they're kind of along the right line of thinking here. Okay, but you do want to put in more specifically CPCFC and then transitive property of congruence. All right. I'm going to go to the next slide here. And so there's all these different properties of equality. We have addition property of equality, subtraction property, multiplication property, division property, reflexive property, symmetric property, transitive, substitution. Okay, so these are properties that maybe could show up in a proof as a reason. Okay, so if you're trying to prove something is true, you might be using something along this table, which would be a good thing to just like do a screenshot of and put in like digital notes. I'm going to give you time to do your notes tomorrow in class. Okay, and so when you go back to watch the video, you can do that. You are also going to have a similar problem to something like this. So if I want to find the value of y, and let me come back. I don't think I was presenting the right tab. All right, so if you want to find the value of y, and you're looking at this crazy picture here. So triangle ABC is congruent to triangle TUV. We know that corresponding parts of congruent figures are congruent. So A, angle A, T, angle T, A and T are congruent. B and U are both the middle letters, so angle B and angle U are congruent. The last two letters, C and V, so angle C and angle V are congruent. They have the same measure. It's also true about the side lengths. So you want to think about the same order when you're trying to pair the stuff up. AB, that side length, is going to be congruent to side length TU. So AB, TU. BC, UV. BC, UV. Okay, and then there's the third one, which is AC, TV. AC, and then TV. Now, that's just kind of understanding what you're looking at. We're looking at two triangles with congruent parts. Corresponding parts are congruent. And so how could I solve for y? What equation could I use to solve for y? And y is not one of these capitalized letters. Y is the variable that's showing up. See, there's a 4y here, 4y here, a 3y here. So basically, if I take two expressions that include y, and I can set them equal to each other from using what I know about corresponding parts, I can make an equation to solve for y. I'm not asking you to actually solve for y, I'm just saying, how could you set it up so that you could? So angle B, you can see this little degree mark right here on angle B, is 3y plus 2. And angle B we know is congruent to angle U, and there's a little line showing me that this angle measures 4y minus 18, and it's a degree. So these are the angle measures. Since those two angles are congruent, their measures are actually equal. So if I want to solve for y, I would take those two expressions, 3y plus 2, 4y minus 18, and just set them equal to each other because I know they're equal to each other because they are congruent angles. All right, so your last question here, it's multiple choice. Now, instead of finding y, say I want to find x. What equation could I set up and use it to solve for x? You don't have to actually solve for x. I just want you to figure out which equation would let you solve for x. What can you deduce from this picture, knowing that corresponding parts of congruent figures are congruent? What two pieces that have x's are actually equal to each other? So go ahead and go to your Pear Deck tab if you haven't yet, and you're going to pick. You have three choices. Is it A, B, or C? There's x shows up in different places on these triangles. Okay. I can't just set anything I want to equal to each other. I have to make sure that they're corresponding parts. I know the triangles are congruent because it tells me that it's given. So how could I figure out what x is? What two things that are shown are actually the same measure? I have 6 responses, so if you haven't chosen one yet, go ahead and choose. And then come back to our meet. Any more than 6 responses? 7 responses. There we go. Keep them coming. Pick one. What equation could you use to solve for x? We have 8 responses. Nine responses. Ten responses. We're halfway there. Okay, so let's see what we're coming up with so far. We're torn between A and B, which is good that so far no one's picked C, because C, well, doesn't even have x in it, right? So if you didn't pick C, good job. If you didn't pick anything, you need to participate. So we're kind of torn between A or B. So just looking at, we have 6x plus 2. Does that equal 5x plus 7? Or does 6x plus 2 equal 6x minus 1? If I hide our responses, here's 6x plus 2, which is side length CB. So if I look at the triangle, it's the last 2 letters, C and B. So the last 2 letters, U and V. There's U, there's V, and the expression that represents its side length is 5x plus 7. So 6x plus 2 would equal 5x plus 7 because they're the same measure. So A is the correct answer. All right. That is the end of this lesson.